We're going to start this video by going over the definition of a derivative at a point. So the formula for the definition of a derivative at a point is the limit of, as h approaches 0, of f of x plus h minus f of x all over h. And so we're going to go over an example. And so the example will be the limit as h approaches 0 at x plus h squared sine of x plus h minus x squared sine of x all over h. And so we're looking for x is equal to pi over 2. So as you can see, the function f of x would actually be x squared sine of x. So what you're looking for essentially is going to be the derivative of the function, which again is x squared sine of x. And so we're going to be using the product rule to find the derivative of x squared sine of x. So the product rule says that u v prime plus v u prime is going to be the derivative. And so first you set the function x squared sine of x into these variables. So u is going to equal x squared and v is going to equal sine of x. And u prime is going to be 2x and v prime is going to be cosine of x. And then you just follow the formula, so you will go u times v prime, so you have x squared times cosine of x plus vu prime, which is going to be 2x times sine of x. So 2x sine of x. And this is going to be your derivative of the function. And now you will plug in x equals pi over 2 because that is the derivative at a point that you want. So that will become pi over 2 squared cosine of pi over 2 plus 2 times pi over 2 sine of pi over 2. And so now you just evaluate, so it'll become pi over 4 times 0 plus 2 pi over 2 times 1. And so 0 times anything will equal 0, so that's out. And then this times 1 will just become 2 pi over 2, and you'll simplify, so the answer will just be pi. So the answer to the limit as x approaches 0 of x plus h squared sine of x plus h minus x squared sine of x all over h at the point x equals pi over 2 is going to be pi. And another example of the definition of a derivative would be the limit as h approaches 0 of x plus h squared all over tangent of 8x plus h minus x squared of tangent of x. And again, you will be looking for the point at x equals pi over 2. So again, according to the formula, the f of x, or the function, is in this, all over h. the function f of x will become x squared over tangent of x. So equals f of x. So you are looking for the derivative of x squared over tangent of x. So to do this, you'll use the quotient rule. And the quotient rule is vu prime minus uv prime all over v squared. And a good trick to memorize this is going to be low d high minus high d low all over low squared. And the low and the high refers back to u over v, where this is going to be high because it's on top, it's higher than the v, and v is going to be low. So you would go low, so v times the derivative of the high, which would be the derivative of u, minus high, so u times the derivative of v, u v prime, all over low squared, which is going to be v squared. And so setting this equal, u would equal to x squared and v would equal to tangent of x. And u prime would equal to 2x, and v prime would be equal to secant squared of x. And we know that the derivative of tangent is secant squared because of the derivative of trigs. So for a moment, we'll go into derivatives of trig functions. So the derivative of sine of x is equal to cosine of x, while the derivative of cosine of x is equal to negative sine of x. And then the derivative of tangent of x is equal to secant squared of x, while the derivative of cosecant of x is equal to negative cosecant of x times cotangent of x. And then the derivative of secant of x is equal to secant of x tangent of x, while the derivative of cotangent of x is equal to negative cosecant squared of x. Okay, so upon further thought, x equals pi over 2. When you plug that into tangent, that would make it undefined. So instead, we are going to use x is equal to pi. So our equation is, well, your derivative is 2x tangent of x minus x squared secant squared of x all over tangent squared of x. And so now you would plug in your pi. So when you plug in pi, it'd be 2 pi tangent of pi minus pi squared secant squared of pi all over tangent squared of pi. So 2 pi, it'd become 2 pi times 0, because the tangent of pi is 0, minus pi squared squared times 1, because the secant squared of pi is 1, all over 0 squared, because again, tangent of pi squared is just going to be 0. So it's going to be negative pi squared all over 0, but since you're dividing by 0, the final answer is just 0. So the answer to the initial equation, the limit as x approaches 0 of x plus h squared over tangent of x plus h minus x squared over tangent of x all over h at the point x equals pi is going to be equal to 0. I am so sorry, but I made a mistake. The final answer to the last question should be undefined because it was divided by 0, and this marks the end of my video. Thank you very much.